All right, so there's definitely a few upgrades going on with the procedural terrain this time. One of the key things is that this is automatically running on its own on a loop where it keeps reusing the same points, but once it finds something, it moves on to another configuration and tries that. And also, another key thing is that the connection lines are filled in now. So there are guaranteed pathways from one point to another where a line connects them. And of course, I can turn off gizmos, so we just watch this flow on the shape of the terrain and kind of see this terrain as just run as it is, which is kind of interesting. It runs a little bit faster in this mode, and I'm not entirely sure why. I think it has less serialization issues and just allows its internal update system to run. Anyway, so let's turn the gizmos back on. So we've got gizmos there, and now let's select the terrain. So it feels choppier when it's selected. I don't know, maybe there's something on it. But let's go shaded wireframe so we can actually see some of these details on how it flows and drops. And anyway, so let's start taking a look at exactly what's going on, because I added a few things. One is that, so we have this new connections mod layer. Let's jump into that. So the first things on it is the path width. I can reduce this down and we see a very thin path line show up between any of these points. You know what? I don't like that mode. Let's go to here. So we see this, and let me go ahead and put a pause on this one. So let's just stop. So we can see over here that it did guarantee that there's a pathway there. Now, keep in mind that that pathway also is based on a width, so from 15 meters out. Now, on this terrain, which is 1,000 meters wide, its height map resolution is 129, which basically means each one of these is about 8. It's about 7 or 8, 8 or 9 units across, or meters across from one height point to another. So back to this one. Between this spot to this spot is about 9 meters. Okay, so it's pretty large. That means at 15, we're really only going to see about 2 to 3 of these get separated out. Okay, so if I increase the width, which, remember, this is all happening dynamically. Anytime I make changes, it recognizes that there's the change and applies it. So I can see that happening immediately. I can also change the slope of this. So we can see that we have a centralized path that is allowed through, but at the same time, it morphs into the terrain surrounding it better. So that means if I'm over here, whatever, I'll reduce the radius of the individual spots, and let's have it continue now. So we can see this flow. It's got the lines. It guarantees a path. Now, at this smaller path line, this is a design trait again. Now, keeping in mind that later on we will be able to add curves and variations showing up to pathways so that they're not necessarily straight lines, but things that fall in line with certain natures of the terrain or certain rules of the terrain on however we apply it. Okay, so I'm not too concerned about the straight lines, but I do want to effectively just show how this code is working. So I added a new feature on here, keep running. If I turn keep running off, once it finishes the process for one, it stops. So there, it stopped, and it didn't move on to the next one. But if I turn on keep running and then tell it to start processing again, once it finishes its evaluation, it resets all the connections of the nodes and then reprocesses it, lets it reprocess under that new structure. Okay, so let me turn this back to shaded, and let's zoom out a little bit and see how this stuff is working. Code, connections layer is the important one. Let's go into here, and it's a little on the large side, so let's go through this. For one, I created a new asset, or a new scriptable object, and this one is force graph connections layer. From this one, I decided to add a tooltip. I was planning to start going through and adding tooltips to all of them, but I haven't really done that yet, and maybe I will, maybe I won't. I'm just going to use the video for now to discuss what this does. Okay, so path width is 5. So it's saying 5 meters out by default from that center line. How many meters from that line does it count? Next, we've got animation curve, path wall shape, and so this is the shape of it. If it's a bowl, then it's just going to curve back into its original shape of whatever the terrain was at that particular point. Next, we have, just like the actual node layer itself, where it has that circle surrounding a node, we have a mesh and a mesh strength. So how much of that mesh is being applied? How much of the update of this new drawing line is being applied? Okay, so same thing on validate. On validate, we tell the tool to validate itself again. Next, rebuild. On this one, I added a new function to force graph, to the tool, to the terrain tool, to be able to get layer. So if we pass in a type, one of the mod layers, it will retrieve that out of it. Now I chose this way in specific versus the idea of having a reference to it from this scriptable to the other scriptable, because if I change which ones are inside of the terrain tools, which ones are being used right now and applied, in case I have multiples, I want to know which one I'm using. Now, this does not account for when there are multiple of the same type being set up, which we could do inside of this. But I don't think we actually would. I don't think we actually would, because any time that we are expecting to reference something else, we should be expecting that there's only one by the nature of what it does. Okay, so anyway, we call it out, then we throw an error if we can't actually find the force graph. And then at some point it's going to error out the first time we try to access force graph from there, if we haven't done anything. But at least it reported what was wrong first. I suppose I could have just exited the rebuild at this point. All right, so next, I create a list of content, vector 3s. The content, these are all of the lines that are connected. So it's a vector 3 array, and that it's going to have 2 every single time, 0 and 1. And the first one will be the first point in the connection. The next one will be the next point. Now, I also did another thing. On the nodes, I added an ID. The ID doesn't do much. So inside of here, when I look at the ID, I have public int ID, and I just put in a public static previous ID that we could get at any point that we try to access node. And then on the constructor for node, I just set the ID to 1 more than the previous ID and increment the previous ID at the same time. That makes sure that every single node, when it's constructed, has a unique ID from the previous one. Okay. Now let's go back. So in order to get, when I'm going through every single node, since the connections are two-way, I needed a quick way to be able to guarantee that I wouldn't rerun the same ones twice. I could do it, but I wouldn't want to. I want to improve the performance where I can on this. Okay, so from this one, all we do is we just say as long as one node is greater than the other one, then we will skip it. And that kind of guarantees that which direction of the node connection are we on. Because since each one has a different number, one will be greater than the other one. So when we look at it from the other side, it'll be the opposite direction on what's greater or less than. Okay, next, in this case, we are adding the content, and we're setting all of the key features that we need at this point in time. So it's its position, plus the scaling of it, because we're stretching this content out, plus the anchor, the offset of what we're using. Okay. Next on this one, when we're using this, we have our mesh that we are resetting to a new mesh. We are setting a new mesh strength for how much of that mesh value we're going to apply. And now we go through each one of these items. Okay, so from every point in the height res map in the mesh, we're gathering its real world position. So we're gathering its real world position as P, and then we're setting the Y value to be the same. Now, the reason that is particularly important that we're resetting the Y value is because that is also dictating the distance. So if we move that terrain really high up, then that anchor point is going to be higher up. And if we also make this more complicated about different heights of different objects, which I likely plan to get into later, or right now I'm planning on it, but I'm not sure of my approach yet. There will be things about obtaining the correct Y position for where you are located, and that it does need to modify the terrain no matter where it is. It needs to get its position as if it matched, which means effectively that the P position needs to, this position does need to match up with whatever the C's, the connection points have. Whatever point in the line it is. So right now I'm running a function, a special function called helper.closest point on line segment. And I don't understand all the math on this one. I had to find it online. And so I found several different references where they were talking about closest point on a line segment. And I went through them and produced my own based off of them, and despite having rewritten it for myself, I'm not that strong of a mathematician. So if somebody happens to understand why this works, that would be awesome. But effectively, closest point on the segment returns whatever point on the line is closest. So if the line is basically my finger right here, and I have a point that's right there, it's going to give me a spot just right in the center of the line. But if I have it way over here, it's going to connect me basically to the end point right over here. If I have it like right here, it's going to connect me close to the end point, but right about there. The point is that we want to find effectively how far we are from the line. Now, I have never worked through this math myself, but here it is. Diff equals line B minus line A. So at this point, we are just getting the difference from line A and line B. Next, we're getting the length of it, and then we're getting the normalized value of it. Now we get diff A, which is whatever our position is, the position that we passed in, and we're saying, well, what's the difference between this and line A? Now we're using the dot product that we clamp down. The clamping is to limit it because we're doing a line segment, and if we don't clamp it, it basically acts like array that just goes on forever. But we're using the dot product to compare the difference of A to the normal, the difference normalized from the previous one. And then, of course, the variables for the clamping. And finally, we return line A plus normal times dot. I'm a little bit lost on this part right here, what exactly it's doing and even why it's doing some of this other stuff. Anyway, if someone can explain that one to me, I would love to see it, or a video on it. That'd be really useful. As I've said before, I do lots of procedural geometry. I do tons and tons of 3D math, but I'm bad at math. Okay, so let's move on. The next section in here, after it gets that closest point, is we get the distance. So if our distance is greater than the path width, then forget it. We just continue on. We're not going to modify the mesh or the mesh height at all. They'll both be just 0. But assuming that our distance is under the path width, then we get the percent difference of it, and we get the applied percent. That's it running through our wall, through our slope that we applied to give it that shape of how it transitions from the original terrain height to the path terrain height. Next, I set that target height here. So the height is already set. That is the height from over here that we get from the anchor position. But then the strength is based off of the applied percent. Okay, and then finally down here, we're doing one other thing because I'm adding the mesh strength from every single pass on this. So basically, if 2 points are kind of bowl-shaped, and they're coming together, where they overlap, we actually combine them, so it kind of flattens out the connections between each other, and we don't end up with some awkward ridges on them. But there's a chance that it's going to exceed 1. And if it exceeds 1, then we're going to have a multiplier of whatever height it is times whatever that last value was that got added to it. And that raises up the edge and we certainly don't want that. We want it to be closer to flat. Anyway, so we guarantee that it doesn't go beyond 1. Then the apply is the exact same apply that we saw on this mod layer. So on this one, where can I find it? Is that assign random connections? That's not the one. Okay. Why can't I find it? Apply. Oh, yeah, this is it. Here, apply. I was looking too low in the code. So over here, we go through each X and Y. We go through the overlay strength, the rest of the strength, and I went through that in one of the past videos, so I'm not planning on covering it in detail again, but this is the same code. Both things are doing effectively the same thing. They just have a slight difference in how they're determining where to apply these values. But once it's got this, it's defined its mesh, and the mesh gets applied in the same way. Okay, that's the key differences. Now there is another one. So we also have, terrain mod layer, visualizer manager. I think it's the terrain mod layer. No, not that one. Terrain force graph terrain mod layer. Okay, this one I added some new booleans to. So I added the keep running variable, and this is to allow it to just keep executing in the background, which that was great for testing because in my code, I have been being very careful to allow recompile and continue playing to keep operating, which means that I don't have to make changes. I don't have to stop the code or recompile things. All I have to do is just save the code files when I'm working on them, and the changes immediately carry over here, and all the values keep operating, which is really awesome. I have to say, it's nice to be able to live in a development environment like that. Anyway, so keep running equals false, so it doesn't get used by default, but let's follow down where this is. So if we're executing the force graph as a single step and we've reduced the iteration on it, I do a check here to say if iterations remaining are less than 0, basically the same stuff here that causes us to do an onValidate, or that marks that it's finished, and we're marked for keep running, then I reinstantiate the nodes. So basically if we're running it in single step only to execute for that, and we don't have any iterations left, start a new one. That's it. Okay, so let's go back to the visuals on it because I just really like watching this. But let's make a change to the code as well. So if I were to change the code and add something to this, what can I add to this? Let's go to here and let's say that distance times path width times 2. Return, and you see the path width in here? The path width should double when it continues and pick up right where it left off. So it's still doing its update, but let's watch what happens. And maybe times 2 wasn't enough to stand out. Why don't we try is greater than path width times 4. Okay, so that should double this, theoretically, unless I did something wrong. Oh, what's going on here? Is it unhappy with a piece of code? Clear. Well, it's still running, but obviously this didn't have the effect that I expected on it. If distance is greater than path width, divided by 4. There we go. That one caught it. So, but you can see that the code is still executing and running. Now, what did I do wrong here? Is greater than path width times 4, but distance divided by 4. Wouldn't that have been the same thing? I'm obviously not in this case, but anyway, I don't want that code. I want the actual numbers getting through, so I'm going to return to this, and this go back to thin lines as soon as it's done. Okay. Anyway, that is the key result of this. I hope you ended up enjoying this, and I would love to hear about other places and ideas that you want to see this start to work out into. I think for now I'm probably done with this. I may be doing some modifications, or I'm done with just the terrain manipulations by themselves. I think for the next sections, I'm probably going to get into how do we color the terrain. And based off of different terrain styles and different which side of the purlin slopes that we're on, how those get applied, the heights that they might get colored on, the normals, the angles of those terrains, and how that might affect it. And then also the steepness of the terrain. Unity terrain has this really kind of ugly edge to it where if it's right on the right side of it, then you get these flat edges that look fine, but otherwise you get these teeth that show up, and that's just really weird. But the reason it's happening is because this is literally what we're seeing in the terrain. We've got these square shapes that follow this grid pattern. So I'm planning, one of the things in this is that when you have steep edges like that in your terrain, you usually want to put in additional models. You usually want to put in additional models like rock objects or elements. So I'm planning on having something like that as well. And then also taking advantage of putting additional features and characteristics on the terrain for those spots. So when one of these spots is sitting and trying to find a particular area, that it will get set up and automatically gain certain characteristics, like there is a resource here to use, or there is a starting player point here. Whatever types of characteristics that I'm going to want in an end game, which is very much up in the air and just to show as examples for right now. All right, I'll talk to you later.